we now try to use the definition to find a definite integral. So we have this one, integral from 1 to 6, and here we have x cubed and plus 1, okay, and dx. So this is what we have. Now because a is 1, b is 6, according to the setup we have done, this is the Riemann sum we have, and we want to take the limit. N is approaching infinity, and here we have b minus a is 5, and we have n at the bottom over here, and we have sigma. We're going to use the sigma notation, and I goes from 1 to n, and then here we plug in the values inside. Remember, xi over here we have the following using the right end point method. This is what we have. This is a plus b minus a over ni. This is what we have. And in our case, this is simply 1 plus 5i over n, right? So we now plug this point inside. We have over here, we have 1 plus 5i over n and cubed, and then plus 1. Okay. Now, next step, we need to expand this one over here. So we have something like I squared, I, and other kind of thing. So we need to expand this expression inside this sigma notation. So what do we have over here is limit, okay, n is approaching infinity, and 5 over n, copy, and sigma over here. Now we use the formula of a plus b cubed, that formula. So we have 1 cubed, right, it's 1, and then plus 3 times 1 squared and this one. So we have 5i over n, okay, and then plus 3, 1 times 5i squared. So it's going to be 5i over here over n squared. Okay. And the last term, of course, is the cubic term, 5i over n. And then we have this one cubed over here. And still we have a 1 over here, right? That's the one we have. Now, let's look at these 5 terms. This is 1, this is 1. They can be put together as 2. This one over here is 15i. This one over here, 3 times 25i. And this one 5 cubed, I cubed over here. So now we do some kind of calculation over here, just getting ready for the summation over here to work. So we have n is approaching infinity, and we have 5 over n and sigma, still the sigma sign. Remember, this is just adding all these things up. I goes from 1 to n. Let's add these two together. So we have 2, the constant term. And then let's look at the second term. We have 15 over n, and then we have I. Now, when we add up these things over here, n is fixed. N is a parameter, say how many terms. I is changing because I goes from 1 to n. So 15 over n is a constant inside our sigma notation over here. Now let's look at the second one, third one over here. 5 squared is 25 times 3 is 75. So we have 75 and n squared. And then we have I squared over here, right? And then we have this one, and that's what we have. 5 cubed is 125, and divided by n cubed and I cubed. Now, if you look at this expression over here, we did it on purpose that put these things in the front because they're coefficients. And then we isolate I and I squared, I cubed out. And now we are ready to move the sigma inside. Now this step over here, we just explained in the previous tutorial. So now we can just apply the method we just practiced over here. So this is 5 over n. But now we put this sigma inside. Remember, everything is inside a big pair of parentheses. So we can actually now add it over here. I goes from 1 to n. And this is 2. This is first one. And then we have the second one over here. And I goes from 1 to n. Still the same thing. We move it inside. And 15 over n. You can pull 50 over n out, but let's, for the moment, we can put it over here as well. 15 over n. Let's do this one for the next one. Okay. So what we have over here is 75 over n squared, and then we have sigma I over here is from 1 to n and I squared. Look at this one. This is exactly what we had before. But of course, in our problem over here, we have another kind of sum that's I cubed. So this one over here, we have I over here goes from 1 to n and I cubed. Now we're going to apply the formulas we know. So let's look at over here. We just copy. This is the limit over here. Don't forget the limit yet. N goes to infinity. And we have 5 over n. Okay. Now inside this big parenthesis, what do we have over here? This is really just 2 plus 2 plus 2. We have n copies of 2. 2 plus 2 is 4. 2 plus 2 plus 2 is 2 times 3 is 6. So what do we have over here? Since we have n 2's, this is 2 times n. Now by this one over here, we have 15 over n is factored out. Now we have sigma I. That's the one we know. It's n plus 1 over 2. So this part is sigma I goes from 1 to n I. That's the one we have. Now look at this one over here. We have 75 and then n squared over here. And then this one we know the formula is n plus 1 and 2n plus 1 and divided by 6. And still yet we have the last term, and that's going to be 125. Just to be patient, we have to do these things separately. And n cubed over here. And this one over here, we remember, that's n plus 1 squared over 2 together over here, squared, right? That's what we have. And everything is inside this big parenthesis multiplied by 5 over n. Now we multiply 5 over n to each term we have over here. So this is what we have. After simplification, we have limit over here. N is going to infinity. And the first one is 10. N and n, they cancel. Second one over here, we have 5 times 15. That's again 75. So we have 75. Now this n is cancelled with this one. So we have over here, in the bottom over here, we have 2 times n over here, and then n plus 1. And we see this limit goes to 1, so it's 75 over 2. Okay. And this one over here, just to be careful, again, n is cancelled over here. So now we have 5 times 75. So we have 375. Okay, so we have 375. And then we have n plus 1. Then we have over here n plus 1. And we have 2n plus 1. And divided by over here. We have 1n is gone, so we still have 2 n's and 6. So we have 6 over here. And then we have n squared. That's right. And then just be careful. And then we have 125 times 5. That's going to be 625 over here. And when here we have n squared and n plus 1 squared. So you can cancel n squared over here. And then we end up with something like this. It's going to be n plus 1 squared in the numerator over here. And inside the denominator, what we have over here is still n squared. We have 1n from here, and 1n is left from over here. And then 4, because 2 squared is equal to 4. Okay. Now let's take the limit. The first one is simply going to be 10. Okay. Second one over here, we have 75 over 2. 75 over 2. Okay. And look at this one over here. This is 125 over 3, because over here is 3 over here. So what we have, this one, the limit, if we do it carefully, then this one over here is 125. How about the last one? The last one over here is 625 over 4. If we add up all these numbers, I believe the answer is 1,315 over 4. Okay, done.